Imagine the vast silence of the universe, a canvas stretched across eternity, where light itself whispers secrets from the edge of time. In this infinite expanse, a colossal shadow lurks, not born of darkness but devouring it, a black hole so ancient, so immense, that its very existence rewrites the story of creation. Picture a cosmic dawn, when the first stars flickered like hesitant flames in a primordial fog, and there, hidden in the glow of a distant galaxy, a monster awakens. This is no mere void, it is a gravitational titan, pulling galaxies into being even as it challenges everything we thought we knew about how the cosmos grows. We gaze into the abyss, and it stares back with the weight of billions of suns, defying the timelines we've etched into our theories. How could such a behemoth form so soon after the Big Bang, when the universe was but a babe, its elements still cooling from the forge of existence? This enigma, nestled in a galaxy named CAPERS-LRD-z9, beckons us to question the very foundations of black hole birth and the dance of galaxies around them. It is a riddle wrapped in starlight, urging us to peer deeper into the night sky, where mysteries unfold like petals in an unseen bloom. Consider the sheer audacity of this discovery, a black hole with the mass of 1.6 billion suns, emerging when the universe was scarcely 400 million years old, a time when the cosmic clock had barely begun to tick. In our earthly experience, we might compare it to a towering oak, sprouting fully grown from a seed in mere days, uprooting the soil of established botany. Yet here, in the celestial realm, it forces us to confront paradoxes of time and matter, where gravity bends not just space but our understanding of evolution itself. The light that carries this secret has traveled for over 13 billion years, a journey through expanding voids, redshifted into infrared whispers that only our most sensitive instruments can hear. It evokes a sense of awe mingled with unease, as if we've stumbled upon a forbidden chapter in the universe's diary, one that hints at forces more primal and voracious than we dared imagine. We stand at the threshold, our minds alight with the poetry of the stars, pondering the silence that precedes creation, the light that defies oblivion. In this enigmatic dance, the black hole becomes a personified force, a cosmic predator whose hunger shaped the dawn, its gravitational symphony resonating through the ether, blending the sense of ionized gas with the chill of infinite night. And so, we are drawn in, our curiosity a bridge across the abyss, wondering at the hidden radiation that pulses from its core, a subtle hint of the death throes of stars long consumed. As we venture further into this cosmic tapestry, let us set the stage on a grand scale, where the universe unfolds its drama across billions of years and light years. The cosmic dawn, that ethereal epoch roughly 400 million years after the Big Bang, was a time of transformation, when the dense, hot plasma of the early universe cooled enough for the first stars and galaxies to ignite. Imagine the scene, a murky soup of hydrogen and helium, pierced by the ultraviolet fury of massive stars, ionizing the gas and carving out bubbles of clarity in the fog. Galaxies were not the majestic spirals we know today. They were chaotic nurseries, clumping together from the gravitational whims of dark matter scaffolds. Amid this frenzy, black holes, those inescapable pits where gravity triumphs over all, were thought to emerge modestly, seeding from the remnants of exploded stars, growing slowly by accretion over eons. But CAPERS-LRD-z9 shatters this narrative. This galaxy, observed at a redshift of Z9, meaning its light has journeyed over 13 billion years to reach us, harbors a supermassive black hole with a mass equivalent to about 1.6 billion suns. To put that in perspective, our own Milky Way's central black hole, Sagittarius A2, weighs in at a mere 4 million solar masses, and it took billions of years to accumulate. Here, in the universe's infancy, when time itself was young, this monster defies logic. How did it balloon to such proportions in under 500 million years? Theories suggest black holes grow through mergers or by gorging on gas, but the rapid assembly required here implies mechanisms we've yet to fully grasp. Perhaps direct collapse from enormous gas clouds, bypassing the stellar remnant phase, or hyper-efficient feeding frenzies in the dense early universe. Visualize the galaxy itself, a compact star-forming powerhouse, its light stretched and dimmed by cosmic expansion, yet brilliant enough to be captured by our most powerful telescopes. The environment was hostile, radiation baths, turbulent mergers, the constant pull of dark energy stretching space apart. Yet, In this cradle of chaos, the black hole not only survived but dominated, shaping the galaxy's evolution. Its gravity sculpted the distribution of stars and gas, perhaps accelerating star formation or quenching it in bursts of energy. Compare this to a seed in fertile soil, but one that grows into a towering tree overnight, uprooting the garden around it. Emotionally, this discovery evokes a profound reverence. We are witnesses to the universe's autobiography, written in the ink of ancient light. The scale humbles us. Earth a speck in the solar system a grain in the Milky Way, and our galaxy one among trillions. Yet through this lens, we connect to the origins, feeling the pulse of creation in our veins. The black hole's presence challenges models of galaxy formation, suggesting that these cosmic engines powered the Reionization era, flooding the universe with light and clearing the cosmic fog. It's a reminder of the universe's layered beauty. Beneath the visible splendor lies a web of invisible forces, where gravity weaves destinies across voids that could swallow civilizations whole. To expand on this, consider the intricate details of the reionization process. Massive stars, born in these early galaxies, emitted photons energetic enough to strip electrons from neutral hydrogen atoms, transforming the opaque universe into a transparent one. Simulations, such as those from the Blue Tides project, illustrate how galaxies like CAPERS-LRD-z9, with their central black holes, acted as beacons, their active galactic nuclei, AGNs, contributing up to 20% of the ionizing flux. This black hole, likely a quasar in its youth, would have shone with the luminosity of trillions of suns, its accretion disk a blazing torus of plasma, converting gravitational potential into radiant energy, with efficiencies approaching 10%. Contrast this with later epochs where black holes grow more sedately. In the early universe, the density was higher, gas clouds more pristine, allowing for runaway collapse without the cooling effects of heavy elements. Philosophically, this evokes a sense of cosmic irony. The very monsters that devour light were instrumental in illuminating the darkness, much like how human innovation, born from conflict, often leads to enlightenment. Delve deeper into the scale. The observable universe spans 93 billion light-years, yet CAPERS-LRD-z9 resides near the edge, its light a time capsule from when the cosmos was 1/10 its current size. Dark energy, comprising 68% of the universe's energy budget, was already at work, accelerating expansion and isolating these early structures. Reverently, we can liken this to wandering through an ancient forest, where each tree tells a story of growth against adversity. But here the trees are galaxies, their roots entangled in dark matter filaments, spanning megaparsecs. The emotional immersion deepens as we reflect on our place. In a universe where such titans formed so swiftly, our own existence feels both fragile and miraculous, a fleeting spark in the grand bonfire of creation. Extending the analogy, imagine the black hole as a cosmic heart, pumping energy through galactic arteries, regulating the flow of starbirth much like a conductor leading an orchestra of stellar symphonies. Detailed astronomical data reveals the galaxy's metallicity is low, around 1/10 solar, consistent with early enrichment from population 3 supernovae, whose iron yields were minimal. The star formation rate, inferred from ultraviolet luminosity, clocks in at hundreds of solar masses per year, dwarfing the Milky Way's modest 1 to 2. This veracity hints at cold gas inflows from the cosmic web, funneled directly to the black hole, evading the disk's turbulence. In this expansive view, we see not just a monster, but an architect, forging the blueprint for mature galaxies we observe today. Delving deeper, we encounter the hidden signals that betrayed this cosmic monster's existence. Subtle whispers in the electromagnetic spectrum, captured not by human eyes, but by instruments attuned to the universe's silent language. Astronomers, peering through the James Webb Space Telescope's infrared gaze, detected anomalies in the light from CAPERS-LRD-z9, broad emission lines, Doppler shifted and broadened by the intense gravity near the black hole's event horizon. These are not mere flickers, they are the spectroscopic fingerprints of gas swirling at relativistic speeds, heated to millions of degrees as it spirals into oblivion. Imagine the light curve, a graph of brightness over time, revealing quasar-like activity, flares of energy from the accretion disk, where matter rubs against itself, generating friction hotter than a star's core. But what makes this detection thrilling is its elusiveness. Visible light from such distances is absorbed by intergalactic gas, so we rely on infrared waves, stretched by the universe's expansion into detectable ranges. The black hole's mass was inferred from the velocity dispersion of surrounding gas, measured via the broadening of hydrogen alpha lines, indicating a gravitational pull that no other force could mimic. Tension builds as we consider the anomalies. The galaxy's star formation rate is extraordinarily high, yet the black hole's feedback, jets of plasma and radiation, should suppress it, creating a paradox. Radio emissions, faint echoes picked up by arrays like the Atacama Large Millimeter or Submillimeter Array, ALMA, hint at cold gas reservoirs fueling the beast, while gamma-ray bursts, if present, would signal violent mergers. These signals are like coded messages from a distant civilization, decoded through algorithms that filter noise from the cosmic microwave background's static. The wonder grows as we realize this black hole, born when the universe was 3% of its current age, challenges the Eddington limit, the theoretical cap on accretion rate, suggesting super Eddington growth, where matter piles on faster than light can push it away. Each data point builds intrigue, painting a picture of a universe more dynamic, more voracious than we imagined. To elaborate on the detection methods, JWST's near-infrared spectrograph, NIR spec, resolved the Lyman alpha line, redshifted to 1.2 microns, revealing a damping wing indicative of neutral hydrogen absorption, a hallmark of the Reionization frontier. The black hole's broad line region, extending thousands of light years, exhibits velocities up to 10,000 km/s, derived from the full width at half maximum of permitted lines like CIV and MGII. Inquisitively, we can frame this as decoding a cosmic hieroglyph, where each wavelength shift narrates a tale of orbital dynamics, with general relativity's predictions confirmed in the asymmetric line profiles. Ground the intrigue in real anomalies. The galaxy's infrared excess, measured by Spitzer legacy data cross-correlated with JWST, suggests dust-obscured star formation, while X-ray non-detection by Chandra implies Compton thick obscuration, hiding the accretion disk's hard radiation. Building tension, consider how these signals were nearly lost amid galactic foregrounds. Machine learning algorithms, trained on simulated spectra, sifted through terabytes of data to isolate the signal-to-noise ratio of 5.1. Poetically, it's as if the universe is whispering through a veil, its voice a blend of thermal hums and relativistic echoes, evoking the scent of heated plasma and the tactile pull of gravity waves. Extend this to case studies. Similar detections in GNZ11, another ZD11 galaxy, show smaller black holes, but CAPERS-LRD-z9's mass implies a growth rate of 10 solar masses per year, far exceeding standard models. The precision of these measurements, with mass uncertainties of 20%, stems from reverberation mapping techniques, timing the echo of continuum variations in emission lines. Wonder intensifies with philosophical digressions. These hidden signals remind us that reality is layered, much like an onion, where peeling back visible light reveals infrared truths, mirroring how human perception filters the full spectrum of existence. In this moment of discovery, we find ourselves drawn closer, our hearts echoing the rhythm of the stars. There is a quiet intimacy in contemplating such vastness, a shared wonder that binds us to the explorers who chart these frontiers. Like standing on a cliff overlooking an endless sea, we feel the pull of the unknown, reminding us that curiosity is the thread connecting our finite lives to the infinite. This emotional tether, soft and warm, invites us to reflect on our own journeys, where the cosmic monster's defiance mirrors our personal triumphs over adversity, fostering a gentle sense of unity with the universe's grand narrative. Tracing back to the beginning, we reconstruct the primordial chaos from which this monster emerged. In the universe's earliest moments, mere seconds after the Big Bang, quarks and gluons danced in a quark-gluon plasma, too hot for atoms to form. As expansion cooled this inferno, protons and neutrons coalesced, forging helium in the fires of Big Bang nucleosynthesis. But black holes? Their seeds lay in the quantum fluctuations amplified by inflation, tiny density perturbations that grew into the cosmic web. For supermassive ones like in CAPERS-LRD-z9, the origin might be direct collapse, immense clouds of pristine gas, unpolluted by metals, collapsing under their own weight without fragmenting into stars. Picture it. A nebula the size of a solar system compressing in freefall, its core heating to form a black hole of 100,000 solar masses almost instantly, bypassing the slow grind of stellar evolution. This happened in the Dark Ages, before the first stars, when dark matter halos provided the gravitational cradles. Over millennia, mergers ensued, smaller black holes colliding in the dense clusters of early galaxies, releasing gravitational waves that ripple space-time, detectable today by LIGO-like instruments. The growth accelerated in the Reionization era, as ultraviolet light from population 3 stars, massive metal-free behemoths, ionized hydrogen, creating ionized bubbles that expanded like cosmic soap films. In this environment, the black hole in CAPERS-LRD-z9 feasted on infalling gas, channeled by torque from galactic collisions. Nostalgically, we evoke the elemental poetry, dust from exploded stars enriching the mix, time stretching like molten glass, birthing structures from void, scientifically anchored, models from simulations like Illustris TNG show how feedback loops, outflows from the black hole regulating star formation, shaped galaxies, preventing runaway collapse. Yet this discovery upends timelines. Standard models predict such masses only after 1 billion years, not 400 million. Perhaps primordial black holes, relics from the Big Bang itself, seeded these giants, or quantum effects in the early universe allowed faster accretion. The rhythm of ancient language whispers through, eons unfolding like scrolls, collapse birthing order from disorder, fire and dust weaving the fabric of reality. To deepen this reconstruction, consider the inflationary epoch, where the universe expanded exponentially, stretching quantum vacuum fluctuations into macroscopic overdensities, with amplitudes of 10⁻⁵. These seeded dark matter halos of 10⁻⁶ solar masses by JWST, providing nurseries for gas collapse. In direct collapse black holes, DCBHs, the critical condition is a gene's mass exceeding 10⁻⁵ solar masses, with Lyman-Werner radiation suppressing molecular hydrogen cooling, allowing isothermal collapse at 8,000 K. Case study: the CR7 galaxy at ZD 6.6, a potential DCBH candidate, shows Lyman alpha emission without metal lines, mirroring CAPERS-LRD-z9's profile. Mergers, simulated in Eagle projects, occur at rates of 1 per 100 million years, each boosting mass by factors of 2, with gravitational wave recoil potentially ejecting seeds unless masses exceed 10⁻⁵ suns. Reverently, imagine the mythic birth, a cosmic womb of plasma, birthing titans and cataclysmic labors, time's arrow-forging chains of causality. Philosophical digression: this origin story parallels human myths of creation from chaos, like the Greek void birthing Gaia, underscoring our innate drive to narrate beginnings. Extend to elemental details. Helium abundance at 24%, set by nucleosynthesis, influenced early gas dynamics, while baryon acoustic oscillations imprinted scales on the cosmic web, guiding halo assembly. The black hole's spin, likely high from gas torques, enables efficient energy extraction via Blandford-Zanajek mechanisms, powering jets that pierce intergalactic medium. In this immersive tale, we feel the nostalgia of lost epochs, the slow forge of elements, carbon from triple alpha processes in later stars, oxygen from supernovae. Yet, in CAPERS-LRD-z9, purity reigned, a pristine canvas for gravitational artistry. These secrets are etched in the record of light, preserved like fossils in amber, allowing us to read the universe's memory. Ancient photons from CAPERS-LRD-z9 carry tales of temperature, composition, and motion, analyzed through spectroscopy that dissects light into rainbows of data. We decode absorption lines from intervening gas clouds, mapping the intergalactic medium's evolution, while polarization studies reveal magnetic fields threading the early cosmos. Particle archives, like neutrinos from the Big Bang, offer complementary views, though elusive. This act of reading spans time. Gravitational lensing magnifies distant signals, bending light around massive clusters to unveil hidden details. Lyrically, data become relics, each spectrum a chapter in the cosmic saga, blending precision with the poetry of discovery. Expanding on this, consider how the cosmic microwave background, CMB, with its 725K blackbody spectrum, encodes the universe's infancy, anisotropies revealing density fluctuations that seeded galaxies. For CAPERS-LRD-z9, 21 cm line observations from future SKA telescopes could map neutral hydrogen distribution, tracing Reionization history. Methodical curiosity drives us to treat quasar absorption systems as time capsules, with damped Lyman alpha absorbers indicating gas reservoirs of 1010 solar masses. Philosophical reflection. Reading these records is akin to archaeology of the soul, unearthing truths that connect past to present, much as personal memories shape identity. The voices of evidence resonate through the scientific community, where real-world endeavors illuminate this enigma. In 2023, astronomers using the James Webb Space Telescope, JWST, announced the detection in CAPERS-LRD-z9, part of the CAPERS survey targeting high redshift galaxies. Led by researchers like those from the University of Cambridge and MIT, the team employed NIR-SPEC to measure the black hole's mass via virial estimates, confirming its antiquity. Earlier hints came from Hubble's deep fields, but JWST's superior resolution pierced the veil. Missions like Euclid and the upcoming Nancy Grace Roman Space Telescope promise more, while ground-based giants like the extremely large telescope will hunt for companions. Timelines trace back. 2010 simulations predicted such early monsters, but this find, published in Nature Astronomy, forces revisions. Human ingenuity shines, teams poring over petabytes of data, their minds bridging eras. To elaborate, the CAPERS collaboration, involving over 100 scientists, cross-referenced JWST data with Subaru Hypersuprime CAM surveys, identifying the galaxy via photometric redshifts. Key figure Dale Kochevsky noted the black hole's bolometric luminosity of 10 or 46 year guess, rivaling the brightest quasars. Grounded respect for discoveries like J0313-1806 at Z07.6, a 1.6 billion solar mass black hole, set precedents, but CAPERS-LRD-z9 pushes to Z09, shortening formation timescales by 100 million years. Lyrical timelines, from Einstein's 1915 relativity predicting black holes to 1971's Cygnus X1 confirmation, culminating in JWST's 2022 launch, a $10 billion marvel with 6.5 ms mirror collecting photons from the dawn. Beneath the visible, invisible landscapes unfold, the event horizon, a boundary where time dilutes, hiding singularities defying physics. Dark matter halos scaffold galaxies, their density cusps fostering black hole seeds. Quantum zones near the horizon evoke Hawking radiation, particles winking into existence. Comparisons abound, like ocean depths concealing abyssal plains, or Earth's mantle hiding convective flows. Suspense builds in the unseen, ergospheres where rotation drags space, extracting energy via Penrose processes. Scale contrasts. A black hole's density rivals atomic nuclei, yet spans light years in influence. Delving deeper, dark energy's lambda term accelerates expansion, isolating early structures, while quantum foam at Planck scales, 10^35 μ, might birth microscopic black holes. Metaphorically, these landscapes are like hidden gardens in a vast estate, blooming with exotic physics, wormholes theoretically linking distant points, or multiverse bubbles beyond our horizon. Suspense rises with analogies to human subconscious, where unseen drives shape behavior, mirroring how dark matter, 27% of universe, dictates visible matter's fate. Against all odds, life persists in extremes, mirroring this black hole's endurance. On Earth, extremophils thrive in hydrothermal vents, their metabolisms echoing potential alien biochemistries. In cosmic terms, perhaps microbes lurk in subsurface oceans, resilient like tardigrades surviving vacuum. Human resilience parallels, societies rebounding from cataclysms, hope blooming in desolation. Wondrously, biology defies entropy, much as this black hole defies formation theories. Extend to case studies. Deinococcus radiodurans withstands 5,000 GY radiation, analogous to radiation-hardy life near black hole jets. Poetically, life's tenacity is a gentle crescendo, comparing microbial biofilms in Antarctic ice to hypothetical organisms in interstellar clouds, fostering hope in the universe's harsh cradle. Expanding outward, refuge worlds beckon. Europa's icy shell hides a salty ocean, potentially harboring chemosynthetic life. Titan's methane lakes mimic prebiotic soups. Enceladus plumes spew organics. Shocking facts. Europa's ocean holds more water than Earth's. Titan's atmosphere rains hydrocarbons. Hope swells in these cosmic oases. Comparisons to early Earth fueling imagination. Detailed exploration. Europa's chaos terrains suggest upwelling, with Galileo magnetometer data indicating a 100-kilometer deep ocean. Titan's Huygens probe revealed ethane rivers, while Enceladus's geysers contained sodium chloride and silica, hinting at hydrothermal activity. Reflective expansion. These worlds as sanctuaries, much like oases in deserts, evoke wonder at life's potential ubiquity. Awareness sharpens through tension, urging us to confront the fragility of knowledge. In this cosmic urgency, we reflect on our place, linking personal awareness to the stars' silent warnings, heightening alertness to the universe's profound interconnections. Scars mirror these cosmic themes. Our environmental collapses parallel galactic feedback, where overexploitation echoes unchecked accretion. Societies crumble from resource wars, much as galaxies quench under black hole outflows. Empathy roots in cause and effect, deforestation scarring Earth like radiation blasts scarring space. Resonant gravity pulls us to consider industrial revolutions mirroring merger epochs, both leaving indelible marks on their landscapes. The collapse in motion viscerally unfolds. Imagine galaxies merging, stars flung into voids, gas stripped in tidal tails. On Earth, climate tipping points accelerate, ice sheets calving, oceans acidifying. Poetically real, the intensity climaxes in multisensory chaos. Roars of gravitational waves, heats of friction, the slow unraveling of systems extend to detailed scenarios. Antarctic ice loss at 150 G-year, leading to sea level rise. Cosmic mergers like antennae galaxies, with starburst rates of 100 solar masses by year, culminating in elliptical remnants. Hidden stakes reveal forces. Political rivalries fund telescopes yet hinder climate action. Economic motives drive space exploration while ignoring ethical lapses. Global analogies. Cold War space races versus modern collaborations. Conflicts simmer without exaggeration. Motives clashing in historical patterns. Deepen with examples. NASA's budget battles amid geopolitical tensions, or private ventures like SpaceX prioritizing profit over sustainability, mirroring how colonial expansions exploited resources, leaving ethical voids. Futures balance on choice. One path to dystopia. Black holes metaphorically devouring hope through inaction. Societies collapsing. Another hopeful. Innovation harnessing cosmic lessons. Sustainable worlds blooming. Responsibility weighs. Reflections lifting emotionally. Visionary forks. Dystopian Earth with runaway warming at +4 degrees Celsius versus utopian fusion-powered societies drawing from stellar insights, emphasizing conditional paths where human agency tips the scale. In reflective closure, we tie threads of wonder, resonating with the universe's poetry. Introspection stirring sincere quiet, a gentle loop back to the enigma's heart. What echoes from the dawn, reframing the metaphor of light and shadow, leaving resonance open in timeless philosophy. Legacy in light connects to humanity's journey. Survival ethics on species scale, lessons echoing across generations. Civilizations rise and fall, but knowledge endures, like ancient light guiding futures. Poetically, we ponder long-view framing, where our actions etch into the cosmic record, a universal tapestry of endurance and wisdom.